Welcome. Tonight we drift together toward one of the most dramatic and most beautiful events the universe holds, the supernova, the explosive death of a star, and the soft glowing remnant it leaves drifting in the dark. There is nothing to do and nothing to hold. Let the wonder be light and let it carry you towards sleep. We will move without hurry through real science and honest wonder, returning again and again to what is calm and true. Each fact is a small distant light offered only to ease your mind toward rest. You do not need to follow every thought. Let the words settle over you the way the faint glow of a remnant settles into the deep cosmic dark. Some things are well measured and certain. Some are still being studied, and all of them are safe to fall asleep inside. Tonight's journey reaches into the brief, brilliant ends of the greatest stars. How a star can blaze for a few weeks brighter than a whole galaxy. How the explosion forges the very atoms within you, and how its glowing wreckage drifts on for thousands of years. So settle in. Let your breath slow and your shoulders ease. Far out in the deep and tranquil dark, the remnants of long-dead stars are drifting and glowing, and we will rest right here beneath that quiet immensity tonight. A supernova can seem like such a distant and violent idea, the bursting end of a star far away, and yet the story folded inside it is enormous, reaching from a single dying star to the very atoms that make up your body. For as long as there have been great stars, some of them have ended this way, flaring out in a brief, brilliant blaze and then scattering their substance softly back into the deep cosmic dark. Tonight we will not rush through that story. We will linger in it, the way a faint remnant lingers for ages in the void, soft and slow and unhurried, glowing gently long after the blast has passed. There is nothing here to trouble you. The world of supernovae is vast and powerful, yes, but seen from far away, it is also deeply peaceful, a place of soft glowing gas, slow expanding shells, and steady, unhurried wonder. So let us begin softly, holding this great cosmic event in our minds, and let the quiet glow of its aftermath become the lullaby that eases you down toward sleep. Here is the first quiet truth of tonight. A supernova is the explosive death of a star, the moment a star tears itself apart in a single great burst of light and matter, ending its long life in one brief, brilliant flare. It is not the gentle fading of a small star, but the sudden violent end of a great one, a blast so vast that for a little while it can shine brighter than billions of ordinary stars combined. In that one explosion, a star pours out more light than it had given in all its long ages of shining, a brilliance that rises swiftly and then slowly fades across the following weeks. And the star does not vanish without a trace, for it flings its outer layers far out into space, where they spread and glow for thousands of years as a soft remnant in the dark. So a supernova is at once an ending and a scattering, the death of one star and the soft seeding of the space around it, a great flare that fades into a long and gentle glow. Let us rest a while on just how bright a supernova can be, for it is one of the most astonishing things in all of nature, a single star outshining an entire galaxy of stars. A galaxy holds many billions of stars, each one shining steadily, and yet when a star explodes, for a few weeks, its single blaze can rival the combined light of all those billions together. From far away, where a galaxy is only a soft, faint smudge of light, a supernova can appear as a brilliant new point gleaming at its edge. Briefly, the brightest thing for vast reaches around. This is how some supernovae are first found. Astronomers noticing a bright new point of light where none had been, a single dying star flaring out against the soft glow of its galaxy. It is a humbling thought to settle into, that one star in its final moment can shine as brightly as 100 billion others, a brief, brilliant beacon in the deep cosmic dark. There is a quiet wonder in the light of a supernova, for it crosses immense reaches of space to reach us, often traveling for many ages before it ever meets a watching eye. A star may explode in a galaxy so distant that its light takes vast spans of time to arrive, so that when we finally see the flare, the explosion itself happened long ago. So in a gentle sense, to watch a supernova is to look back in time, to see an event that finished its blazing long before, its light only now completing its long journey through the dark. The light carries its story faithfully across all that distance, the rise and the fade of the brightness preserved in the beam, a message sent across the void from a star that is already gone. It is a soothing thought to hold, that these brilliant deaths reach us softened by distance and time, faint points of light in our sky, the gentle echoes of explosions long since past. As we settle into the science, it helps to know that supernovae come about in two great ways, two quite different roads that lead a star to the same brilliant end. The first road is the collapse of a massive star, a giant that runs out of fuel and falls in upon itself, its core caving in and its outer layers blown violently away. The second road is quite different, the runaway detonation of a small, dense, dead star, a white dwarf that gains too much matter from a companion and ignites all at once. Both roads end in a great explosion and a soft glowing remnant, yet the stars that travel them and the way they reach the blast are not the same, and we will explore each gently in turn. So hold these two roads lightly in mind, the falling giant and the detonating dwarf, the two great paths by which a star can come to its brilliant supernova end. Let us follow the first road gently, the death of a massive star, a giant many times heavier than our Sun, that ends its life by collapsing in upon itself in a single rushing moment. Such a star spends its long life burning through its fuel, building heavier and heavier elements deep in its core, until at last it can burn no more and its support begins to fail. When the burning that held the star up at last falters, gravity wins and the core falls inward with astonishing speed, collapsing in far less than a second to a small dense knot. The sudden collapse and rebound of the core sends a great shock outward, and the outer layers of the star are flung violently away, blazing into a supernova in the deep dark. So the first road is the giant's fall, a great star burning out, its core caving in, and its body blown apart in one brilliant blast that scatters its substance across space. It is worth resting on why only the heaviest stars end in this collapsing blast, for most stars, including our own Sun, will never explode in this dramatic way. A star must be quite massive, more than about 8 times the weight of the Sun, before its core can grow heavy enough to collapse and trigger such a violent end. Lighter stars like our Sun end their lives far more gently, swelling and then quietly shedding their outer layers, leaving a small warm ember rather than a great explosion. It is only the great giants, the heaviest of stars, whose cores grow massive enough that gravity can at last overwhelm them, sending them collapsing toward the supernova blast. So the explosive death is reserved for the largest stars alone, a rare and dramatic ending that only the heaviest giants ever reach, the rest fading by quieter paths. At the heart of a massive star's death lies a quiet turning point, the building of an iron core, for iron is where the star's long fire finally comes to its end. Through its life, the star fuses lighter elements into heavier ones, and each step gives off energy that helps hold the star up until at last it builds a core of iron. But fusing iron does not give off energy. It takes energy instead, and so when the core is iron, the star's long fire can find no further fuel, and its inner support quietly fails. With no more energy welling up from the core to push against gravity, the iron core stands suddenly unsupported, poised at the edge of a collapse it can no longer resist. So the iron core is the silent threshold of the explosion, the point where the star's fire ends and gravity takes hold, the quiet beginning of the great collapse to come. Let us pause and simply drift for a moment. No new facts now, only the deep cosmic hush, a soft glowing remnant drifting in the dark, a gentle quiet settling over the calm mind. Breathe in slowly and picture a single soft remnant glowing far out in the dark, its gentle gas drifting outward, calm and luminous in the silent void. Breathe out and let a little of that calm loosen your shoulders. There is so much gentle wonder in the deep cosmos, and a little of its peace is yours to rest in tonight. When the iron core can hold itself up no longer, what follows is breathtakingly swift, a collapse so fast that it finishes in far less than a single second. In that fraction of a moment, a core far larger than our whole world falls inward and crushes down to a tiny dense knot, the matter squeezed together beyond imagining. The infalling matter rushes inward at a great fraction of the speed of light, the core caving in with a speed and force the gentle mind can scarcely hold. It is a strange thought that a star which shone steadily for ages should meet its end in less than a heartbeat, the long life undone in a single rushing instant of collapse. So the great explosion is born in an eye blink, the slow fire of ages giving way to a collapse of less than a second, the swift, quiet trigger of the brilliant blast to come. It is a gentle thing beneath the thought of a supernova to feel how small we are, a single quiet life beneath an event so vast it outshines a whole galaxy of stars. The blast of a single dying star releases more energy than our sun will give in all its ages, an event so immense that our whole world is less than a mote beside it. And yet there is no fear in this smallness, only a deep calm, the comfort of being a small quiet part of a cosmos where even the greatest events reach us softened into gentle light. To feel small beneath the brilliance of a dying star is to be eased of the weight of the day, the small worries dissolving beneath an event so vast and so far away. So let your smallness be a comfort tonight, a single quiet life beneath the brilliant depths of distant stars, made of the very substance that such depths once scattered. There is a quiet comfort in the thought that the cosmos renews itself through the deaths of stars, the end of the old sowing, the birth of the new across the long ages. Each supernova scatters the substance from which new stars and worlds may form, so that the death of one generation becomes the cradle of the next, the cosmos forever renewing. So the universe is not a thing of endings alone, but of turnings, the dying of stars folding into new beginnings, the brilliant blasts sowing the seeds of all that follows. There's a deep peace in that renewal, the sense of a cosmos that turns gently from death toward birth, the scattered substance of the old gathering quietly into the new. So let that comfort settle over you tonight, the thought of a renewing cosmos, the deaths of stars sowing new life across the deep dark, the great quiet wheel turning on. Picture as you drift the supernova remnants scattered across the heavens like soft glowing lights, the gentle wreckage of stars that died long ago, drifting calm in the dark. Each remnant a soft luminous cloud of crimson and gold and teal, the scattered substance of a star spread into glowing form, glimmering faintly across the deep cosmic dark. They drift slowly and silently through the void, these soft glowing remnants, the long gentle afterglow of brilliant deaths, beautiful and calm in the immense quiet of space. It is a peaceful image to rest the mind upon, these remnants like soft lights in the dark, the gentle wreckage of dying stars glowing quietly across the great reaches of the void. So hold that gentle picture as you settle, the soft glowing remnants drifting calm and far, the scattered substance of stars glowing softly in the deep tranquil dark. Imagine as you drift a single quiet supernova remnant floating far out in the deep cosmic dark, its soft glowing gas drifting slowly outward, calm and luminous and still. It glows gently against the surrounding void, a soft shell of colorful gas spreading slow across the ages, the scattered substance of a star turned into a luminous cloud. There is nothing to do but watch it drift. This one quiet remnant, its soft light spread across the dark, expanding so slowly it seems to rest in the silent void. Let the eye rest on its slow calm spreading, the soft glow of the gas, the fine luminous filaments drifting gently in the deep and tranquil cosmic dark. So hold that one quiet remnant in mind as you settle, drifting soft and slow in the deep, the gentle afterglow of a dead star easing you toward sleep. To look upon the whole cosmos, with its dying stars and its glowing remnants and its new stars born of the old, is to find not a place of endings but a slow and gentle renewal. Stars rise and live and die, scattering their substance, and from that scattered substance new stars and worlds gather, the cosmos forever turning from death toward birth. It is a slow and gentle renewing, this great cycle, vast beyond imagining yet calm and ordered, the dying of stars folding quietly into the birth of all that follows. So the universe, for all its dramatic deaths, is a place of deep renewal and deep calm, the brilliant blasts sowing the seeds of new stars across the long ages of the dark. It is a soothing thought to settle into, the cosmos as a slow renewing, the deaths of stars giving rise to new beginnings, the great quiet wheel turning gently across time. At the heart of the whole story lies one gentle cycle, the turning of star into dust and dust into star, the substance of the cosmos forever gathering and scattering and gathering again. A star gathers from the dust of space, lives its life, and scatters its substance in death, and from that scattered dust new stars gather in their turn, the cycle ever renewing. From this gentle turning comes all the variety of the cosmos, the generations of stars, the enriched gas, the worlds that gather from the scattered substance of the dying. So the grandest renewal in all of nature arises from this quiet cycle, the star scattering into dust, and the dust gathering into star, turning gently across the long age. It is a peaceful truth to rest upon, this gentle cycle of star and dust, the substance of the cosmos forever turning from one into the other, across the deep, tranquil dark. Let us rest on the gentle giving at the center of it all, the way the old stars give of their substance to the new, the dying scattering the elements the next generation will need. The stars that die scatter their forged elements into the gas of space, and the stars that follow gather from that enriched gas, built in part of the substance of those before. So each generation of stars is a gift from the last, the old scattering and the new gathering, the substance of the cosmos passed gently from the dying to the newly born. Without this giving, the cosmos would hold only the simple young gases, and worlds of rock and the elements of life could never have come to be among the later stars. It is a gentle thought to hold this giving of the old stars to the new, the dying scattering their substance for the generations that follow, the cosmos sharing itself across time. There is a soft beauty in the faint glow of the most distant supernova remnants, their light grown dim across the immense reaches of space, faint, soft clouds at the edge of sight. These far remnants glow only faintly to us, their light long traveling across the deep dark, and yet each is the scattered substance of a star spread into a soft luminous cloud. So even the faintest soft glow in the deepest reaches is the remnant of a dying star, its dim luminance the gentle afterglow of a brilliant blast long ago and far away. It is a lovely thought to rest upon, these faint, distant remnants, their soft glow reaching us across the immensity, the gentle wreckage of stars that died in the far dark. So hold that gentle image as you settle, the faint far remnants glowing softly in the deep, the scattered substance of distant stars drifting calm in the tranquil cosmic dark. Imagine as you drift a single soft shell of glowing gas spreading slowly outward from a long dead star, a great luminous bubble drifting calm across the deep cosmic dark. The shell glows gentle in soft colors, crimson and gold and teal, its fine filaments tracing its expanding edge, the scattered substance of a star spread into a soft, glowing sphere. It spreads so slowly across the ages that it seems quite still, a great soft bubble of light drifting in the dark, the gentle afterglow of a brilliant blast long past. There is nothing to do but drift with it, this one soft, glowing shell, its gentle light spread across the void, the quiet wreckage of a dying star easing through the deep dark. So hold that single shell in mind as you settle, a soft, glowing bubble of gas spreading slow across the dark, calm and luminous and far in the deep, tranquil silence of space. Many of the elements within our world were forged in supernovae older than our sun, scattered into space long before our world ever gathered from the dust of the cosmos. The iron and the calcium and the precious metals of the earth were made in stars that died ages before our sun was born, their substance drifting long before it found our world. So, when we trace the elements within us, we trace something far older than the earth, the scattered substance of stars that lived and died before our world ever came to be. There is a deep calm in that antiquity, the sense of carrying within us the substance of ancient stars, forged and scattered long before our world gathered from the dust. So supernovae connect us to the deep past of the cosmos, the elements of our world and our bodies, the gift of stars that died ages before the sun and the earth were born. Let us follow what happens at the very heart of the collapse, for when the falling core can be squeezed no further, it rebounds, and from that rebound a great shock is born. The innermost core is crushed until it grows suddenly stiff and can give no more, and the matter still falling smashes against it and bounces, sending a shock wave rushing outward. That outward shock plows back against the still infalling layers, and with the help of a vast flood of tiny particles welling up from the core, it drives the outer star apart. So the explosion is in a sense a great rebound, the falling core bouncing back and the shock it makes blasting the rest of the star outward into the surrounding dark. It is a gentle paradox to rest upon that a collapse should give rise to an explosion, the inward fall of the core turning in an instant into the outward blast of the star. There is a soft thread of number running through the story of supernovae, in the speeds of the scattered gas, the limit of mass, the slow, steady rhythm of these deaths across a galaxy. The great speed of the ejecta, the quiet limit of mass at which a white dwarf detonates, the slow rate of supernovae in a galaxy, all follow gentle regularities measured with care. These are not cold rules, but the quiet constancies of the cosmos, the numbers the dying stars keep, the same kinds of explosions arising in the same gentle ways across the. There is a calm beauty in that order, the sense that even the most violent events of the cosmos unfold to a quiet and constant reckoning beneath their dramatic brilliance. So the cosmos keeps a quiet arithmetic of these brilliant deaths, the speeds and the limits and the rhythms, a soft order beneath the blasts, soothing to glimpse and to rest upon. After all we have wandered through tonight, it is worth asking softly why supernovae should amaze us so, why we return to them again and again with such quiet wonder. Perhaps it is the sheer brilliance of them, a single star outshining a galaxy, a brief blaze brighter than billions of suns flaring out against the deep dark sky. Perhaps it is what they make and give, forging the very atoms within us, scattering the substance of worlds, weaving us into a deep kinship with the dying stars. Whatever the reason, supernovae have drawn our wonder ever since the first ancient sighting, and draw it still, brilliant deaths resting calm in the long memory of the sky. So it is no wonder we have come to them tonight, seeking calm in their vast quiet aftermath, and finding in the science and the silence a soft and lasting peace. Supernovae do not stand apart, but live woven deep within the whole of the cosmos, bound to the lives of stars, the substance of worlds, and the slow renewing of galaxies. They forge the elements of worlds and bodies, leave strange dense remnants, stir the gas of galaxies, and measure the very distances of the universe, part of its whole great fabric. And the cosmos in turn would not be the cosmos we know without these brilliant deaths, for the rich variety of its elements and its renewing of stars depend upon them. So supernovae and the cosmos hold each other, each part of the other, the brilliant deaths woven through the whole of the universe's slow and quiet renewing. It is a soothing thought to rest upon this deep belonging, the supernovae nested within the cosmos like brilliant turning points in the long, slow story of the stars. Looking back across all we have spoken of, it is striking how much the careful study of supernovae has taught us about the cosmos, about stars and elements and worlds and ourselves. It has shown us how the greatest stars die, how the elements of worlds are forged, how strange dense remnants are born, and how the very distances of the cosmos may be measured. It has revealed the two great roads to the blast, the brilliant rise and fade of the light, the soft glowing remnants, and the deep kinship between the dying stars and ourselves. And it has done so gently through long, careful watching and reading and listening, drawing the secrets of these brilliant deaths, little by little out of the dark into understanding. So we owe a quiet debt to that devoted study, for all it has shown us of the deaths of stars gathered gently across the years of careful and loving attention to the sky. Now let the great science of supernovae grow soft and distant, all its blasts and remnants and forged elements easing into the background, like a field of stars glimpsed from far away. There is nothing left for you to learn tonight, no light curve to read, no remnant to map. There is only this one moment, and the easy rise and fall of your own breathing. Let the whole story of the dying stars become a soft, dark quiet at the edge of your mind, the science a faint hum, the remnants a gentle glow, all of it calm and far and fading. You are not the watcher now, but the quiet mind at rest, the wondering done, the cosmos grown gentle, the thoughts settling soft as starlight toward their own deep rest. So let your thoughts settle like the slow drifting of a distant remnant, gentle and far, easing quietly into the warm and tranquil dark. Picture, as you settle deeper, the deep cosmos spread calm and vast above you, the soft glowing remnants drifting in the dark, the scattered substance of stars glowing gentle and far. There is no hurry here, no task, no thought to hold. There is only the slow drifting of the remnants, the soft glow of the gas, the deep calm settling over everything. The remnants drift slow and silent across the void, the soft glowing shells spreading gently across the ages, all of it calm, all of it deeply at peace. It is a deep and lovely peace, the peace of the deep cosmos, the universe renewing itself slowly and calmly, the scattered substance of stars drifting soft across the tranquil dark. So let that peace be yours tonight, the calm of the deep cosmos, the soft glow of the remnants, the slow drifting of the gas easing you down toward the gentle dark of sleep. One more gentle rest before we near the end. Let every fact and wonder grow distant and small, like a faint remnant seen from far away, calm and soft and glimmering in the deep dark. You have wandered through the whole quiet world of supernovae tonight, the blasts and the remnants, the forged elements and the deep cosmos, and now there is nowhere left to go but rest. Let the whole soft cosmos settle into a single quiet feeling of peace. The gentle dark deepens around you, and slowly, slowly it lets you go to sleep. We have come a long way tonight from the first brilliant flare of a dying star, through the whole quiet science of supernovae, the collapse and the detonation, the forging of elements and the soft glowing remnants. We found again and again the same gentle truths, that the deaths of stars forge the atoms within us, scatter the substance of worlds, and renew the cosmos across the long ages. There is nothing left to do now but rest. The cosmos is at rest too, the remnants drifting slow and soft, the scattered gas glowing faint and calm across the deep dark. So let the whole quiet cosmos become a lullaby, the dying stars and the glowing remnants and the forged elements all softening into the calm that carries you gently towards sleep. Let go and drift. The remnants will keep drifting slow and silent through the night to come, and tonight the quiet science of the dying stars and the deep peace of the cosmos have eased you, with great care, all the way down toward rest. Our journey is ending now, here in the soft, deep hush of the cosmos, the remnants drifting slow in the dark, the gentle day folding softly toward its close. Let the facts and the wonders fade away like a remnant dimming slow across the deep dark, growing fainter and softer, until only a calm and gentle quiet remains around you. You carry within you now a whole quiet cosmos, the dying stars and the glowing remnants, the science and the silence, and the very stardust of which you are made, resting softly in the gentle dark. Breathe slowly now, and let each breath carry you a little deeper towards sleep, while far out in the quiet dark, the remnants go on drifting soft and silent through the night. Sleep well. The remnants will keep drifting gently through the night to come, and the soft, deep calm of the cosmos will hold you all the way until morning. Good night. There is a hidden marvel in the collapse of a massive star, a vast burst of the faintest particles in nature, the tiny, ghostly things that scientists call neutrinos. When the core collapses, it pours out an immense flood of these neutrinos, so many that they carry away the great bulk of the energy released in the whole explosion. Neutrinos are so faint and so weakly touching ordinary matter that they slip through almost everything, and yet in the dense heart of the collapse, Even they help blast the star apart. It is a quiet wonder that the greater part of a supernova's energy escapes not as light, but as this silent flood of neutrinos streaming out unseen into the deep cosmic dark. So at the heart of the brilliant blast is a great invisible burst, a flood of ghostly particles pouring outward, carrying away more energy than all the dazzling light we see. Let us rest on the moment the star itself is torn apart, for after the collapse and the shock, the great outer body of the star is blown violently outward into space. The shock and the neutrino flood together, overwhelm the star's outer layers, and all that vast envelope of gas, the bulk of the star, is flung away from the small, dense core. The star that shone as a single point becomes in moments a swelling cloud of glowing gas, its substance scattered outward in every direction across the surrounding dark. This is the supernova we see from afar, the brilliant flare of the star's outer layers blasted free and lit ablaze, the great body of the star undone in a single burst. So the explosion is the unmaking of the star's body, its long-held substance flung free at last, scattered outward to glow and drift across the deep cosmic dark. It is worth resting on how swiftly the scattered substance of the star, what astronomers call the ejecta, races outward through space after the great blast. The blown-away gas does not drift gently at first, but rushes outward at thousands of kilometers in every second, a speed so great the gentle mind can scarcely picture it. At such a pace, the ejecta sweeps across vast reaches in a short while, spreading the star's substance ever wider, a great shell of gas expanding swiftly through the dark. Over the long ages, this swift expansion slowly eases as the ejecta meets the thin gas of space, but at first it tears outward with astonishing speed from the exploded star. So the supernova's substance is cast far and fast, racing outward through the void at thousands of kilometers a second, scattering the star across great reaches of space. Let us turn now to the second great road to a supernova, the very different end of a small, dense, dead star, a white dwarf that detonates all at once in a great thermonuclear blast. A white dwarf is the cooling ember left when a small star like our Sun has finished its life, a dense, quiet remnant about the size of a world, but holding the mass of a star. On its own, such an ember would simply cool slowly forever. But if it draws extra matter from a close companion star, it can be pushed past a quiet limit and ignite all at once. When that happens, the whole dense ember detonates in a runaway burning, a thermonuclear blast that tears the white dwarf entirely apart in a single brilliant explosion. So the second road is the detonation of the dead, a quiet ember pushed too far and igniting, blazing out as a supernova quite unlike the collapse of a living giant. There is a gentle threshold at the heart of this second road, a quiet limit of mass beyond which a white dwarf can no longer hold itself up, and so detonates. A white dwarf is held against gravity, not by burning, but by a strange stiffness of its crushed matter, a support that holds firm only up to a certain weight. That limit lies at about 1 4/10 times the mass of the Sun, and if a white dwarf is pushed past it by matter falling on from a companion, its support gives way. As it nears that limit, the dense ember grows hot and unstable at its core until the burning runs away all at once and the whole star detonates in a thermonuclear blast. So this kind of supernova waits upon a quiet threshold of mass, the white dwarf gathering weight until it crosses the limit and then igniting in a single great explosion. Let us rest on the gentle partnership behind a detonating white dwarf, for it is born of two stars together, a dense dead ember and a living companion that share their substance. Many stars are not alone, but bound in pairs, two stars circling one another, and when one has died to a white dwarf, it may draw matter slowly from its still living partner. Across long ages, the white dwarf gathers this borrowed substance, growing heavier as the gas of its companion falls gently onto its dense surface, drawing it toward the quiet limit. So the detonation is in a way a shared end, the dead ember pushed over the edge by the matter of its living companion, the pair together giving rise to the great blast. It is a strange and gentle thought that a long dead star might be brought to a brilliant new end by the slow gift of a companion substance across the ages. There is a remarkable quietness to these detonating white dwarfs, for because they explode at nearly the same quiet limit of mass, they tend to shine with nearly the same brightness. One white dwarf detonation looks much like another in its peak brilliance, since each crosses the same threshold of mass and releases a similar great burst of light into the dark. This sameness makes them wonderfully useful, for if we know how bright such an explosion truly is, then how bright it appears to us tells us how far away it lies. So astronomers call these explosions standard candles, lights of a known brightness scattered across the cosmos, each one a gentle measure of the distance to its galaxy. It is a lovely thought to rest upon, that a class of dying stars should all shine so nearly alike, becoming quiet measuring lights spread across the deep reaches of space. Because the detonating white dwarfs shine with so nearly a known brightness, they have given astronomers one of their finest tools for measuring the vast distances of the cosmos. By comparing how bright such a supernova truly is with how faint it appears in our sky, astronomers can reckon how far its light has traveled to reach us across the dark. In this way, these explosions serve as quiet milestones strung across the universe, each one marking the distance to a galaxy far too remote to measure by any nearer means. Using these standard lights, astronomers found a deep surprise about the universe, that its expansion is not slowing but gently speeding up, driven by something still mysterious. So we will not dwell on that great puzzle tonight, only rest in the wonder that the brilliant deaths of small stars became the very rulers by which we measure the cosmos. Astronomers have learned to sort supernovae into kinds by reading the light they give off, gently separating the collapsing giants from the detonating dwarfs by the colors in their glow. The light of an explosion carries the fingerprints of the elements within it, and by reading those fingerprints, astronomers can tell what kind of star has died and how. Some kinds show the marks of hydrogen in their light, the sign of a great giant still wrapped in its outer gas, while others show none, having shed or lacked that outer layer. By these careful readings, the supernovae are gathered into families, the collapsing giants in their several forms, and the detonating white dwarfs in their own distinct kind. So even from immense distances, by the gentle colors in the light, astronomers can read the manner of a star's death, sorting the brilliant blasts into their quiet kinds. Let us rest on the gentle shape of a supernova's brightness over time, for it does not simply flash and vanish, but rises and then slowly fades across many days and weeks. In the first days after the blast, the light climbs swiftly toward its peak, the explosion brightening as the hot expanding gas swells and glows ever more fiercely in the dark. Then, having reached its brilliant height, the light begins a long, slow fade, dimming gradually over weeks and months as the great cloud of gas cools and thins and spreads. Astronomers call this rising and fading the light curve, a gentle arc of brightness that tells by its shape much about the star that died and the explosion that undid it. So a supernova is not a single instant, but a slow unfolding, a brightness rising over days and fading over months, a long gentle glow following the first brilliant flare. There is a quiet secret in the long fading glow of a supernova, for much of that lingering light comes not from the blast itself, but from freshly made radioactive matter cooling within. In the heat of the explosion, the star forges great amounts of a heavy radioactive form of nickel, and this nickel slowly decays into cobalt and then into iron over the following weeks. Each step of that gentle decay releases energy, and it is this steady warmth from within that keeps the expanding cloud aglow long after the first brilliant flare has passed. So the soft, lingering light of a fading supernova is the glow of radioactive ash, the freshly made elements warming the gas from inside as they slowly settle into stability. It is a lovely thought to hold that the long afterglow of a dead star is lit by its own newborn elements, the radioactive ash of the blast quietly warming the drifting gas. Rest here a while in an imagined stillness, a soft dark sky strewn with faint stars, and a gentle glowing remnant, the deep cosmos spread calm and vast around you, far from any care. You need not picture anything precisely, only feel the gentle quiet settling around you, the remnant glowing soft and far, the great dark calm and tranquil and deep. Let your breathing slow to match that stillness. There is nowhere you need to be, nothing you need to hold, only this deep cosmic quiet to rest within. After the great blast has faded, a supernova does not leave only empty space, for the collapse of a massive star can leave behind a strange, dense remnant at its very heart. When the core of a giant collapses, it is crushed into something far denser than any ordinary matter, a tiny knot holding the mass of a star within a small, dense sphere. What that remnant becomes depends on how heavy the dying star was, for the heaviest collapses leave one kind of object, and the somewhat lighter ones leave another. So the explosion is not only a scattering outward, but a forging inward, leaving at the center a dense remnant born in the crushing collapse of the star's iron core. We will rest gently on these remnants in turn, the dense knots left at the heart of the blast, the strange quiet cores that remain when the great giant has died. Let us rest on one of the strangest things a supernova can leave behind, a neutron star, a tiny remnant so dense that the gentle mind can scarcely hold the idea of it. When a massive star's core collapses, it can be crushed until its matter is squeezed into a small, dense sphere only a few kilometers across, yet holding more mass than our whole sun. In that crushing, the ordinary particles are pressed so close together that the core becomes a single vast knot of dense matter, the neutron star left glowing faintly at the blast's heart. A single small spoonful of such matter would weigh more than a great mountain, so densely is it packed, the whole mass of a star crowded into a sphere the size of a city. So the death of a giant can leave behind this tiny, astonishing remnant, a neutron star resting at the center of the scattered gas, a dense, quiet heart left by the great blast. Some neutron stars reveal themselves in a gentle, rhythmic way, spinning swiftly and sweeping a beam of light across space, and these we call pulsars, lighthouses of the dark. When the great core of a star collapses, its spin grows far faster, much as a turning dancer spins quicker drawing in their arms, so the tiny remnant whirls round at great speed. As it spins, a pulsar sends out beams of light and other rays from its poles, and as the beams sweep past us, we catch a steady pulse, a rhythmic flicker from across the dark. So a pulsar keeps a quiet, steady beat, its beams sweeping round many times each second, a faint, regular pulse reaching us from the dense, spinning heart of an old explosion. It is a soothing thought to settle into, these tiny, dense remnants turning steadily in the dark, their gentle, rhythmic beams keeping a quiet time across the deep cosmic night. For the very heaviest of dying stars, the collapse goes further still, and the remnant left at the heart of the blast is not a neutron star but a black hole. If the collapsing core is heavy enough, not even the dense stiffness of crushed matter can hold it up, and it falls on inward without end, vanishing into a black hole. A black hole is a region where gravity has grown so strong that nothing, not even light, can escape it, a dark, dense remnant left where the greatest stars collapse. So the death of the most massive giants can leave behind not a glowing dense star, but a quiet, dark remnant, a black hole resting at the center of the scattered gas. It is a gentle wonder to hold that the brilliant flare of a supernova can leave at its heart a thing so dark and dense that the very light cannot rise away from it. While a dense remnant may rest at the heart of the blast, the greater part of the star drifts outward as a vast glowing cloud, the soft and beautiful supernova remnant. The blown-away gas, racing outward at first and then easing, spreads into a great shell of glowing matter, lit and warmed by the energy of the blast and its own newborn elements. Over the years and the ages, this shell swells ever wider, a soft, luminous nebula spreading slowly through the dark, the scattered substance of a star turned into a glowing cloud. These remnants are among the loveliest sights in all the sky, great soft webs and shells of colorful gas, the gentle glowing wreckage of stars that died long ago. So the supernova leaves not only a dense dark heart, but a great soft glowing body, an expanding remnant drifting outward, the luminous afterglow of a star's brilliant end. Let us drift among the shells of glowing gas that make up a supernova remnant, for they are shaped in soft layers and rings, the scattered stars spread into luminous form. The gas blasted from the star expands in a great shell, and as it spreads it can take on delicate forms, soft rounded bubbles and rings and layered curtains of glowing color. Within the shell, finer structures appear, fine filaments and knots and wisps, the gas drawn into intricate luminous shapes as it cools and meets the thin matter of space. So a remnant is not a featureless cloud, but a thing of gentle structure, shells within shells and threads within threads, a soft glowing architecture left by the blast. It is a lovely thing to rest the mind upon, these soft luminous shells of gas drifting in the dark, the scattered substance of a star arranged into gentle glowing form. Among the loveliest features of a supernova remnant are its filaments, fine glowing threads of gas woven through the soft cloud, delicate and luminous in the deep dark. As the blast's gas spreads and cools and meets the thin matter of space, it gathers into slender threads and wisps, fine bright filaments tracing the shape of the expanding shell. These filaments can be intricate beyond imagining, a fine glowing lacework spread across the remnant, soft threads of crimson and teal and gold woven through the drifting gas. Each thread glows by its own gentle light, lit by the energy of the blast and the slow cooling of the gas, a luminous tracery left by the unmaking of a star. So a remnant can wear a delicate veil of glowing filaments, fine bright threads woven through the soft cloud, a quiet luminous beauty drifting in the deep cosmic dark. It is worth resting on how long a supernova remnant lingers, for though the first bright flare fades in weeks, the expanding shell of gas drifts and glows for many thousands of years. Long after the brilliant blast has dimmed, the great cloud of gas keeps spreading outward, swelling slowly wider across the ages, glowing softly all the while in the dark. Over those long spans the remnant grows ever larger and thinner, a soft expanding shell reaching across vast reaches of space, the scattered stars spread gently through the void. Across thousands of years the remnant slowly fades and merges at last with the thin gas of space, its substance mingling with the matter from which new stars may one day form. So a remnant is a slow and lasting thing, drifting and glowing for ages after the blast, the long gentle afterlife of a star scattered softly across the deep cosmic dark. Let us linger in a wide and tranquil dark, far from any care, only the soft glow of a distant remnant drifting calm and silent across the immense and gentle void. There is nothing to learn here and nothing to do, only the gentle glow of the deep cosmos, the remnant drifting slow and far in the great tranquil dark. Settle into that same soft stillness. Let it be a place with no demands, where you, like the slow drifting remnant, may simply drift gently and rest in the deep quiet. We come now to one of the most wonderful truths of supernovae, that they are great forges of the elements, making and scattering the very atoms from which worlds and bodies are built. In the heat of the explosion and the long burning before it, the star fuses lighter atoms into heavier ones, building many of the elements heavier than the simple gases of the young cosmos. And when the star explodes, these freshly made elements are flung far out into space, scattered across the dark to mingle with the gas from which new stars and worlds will form. So a supernova is not only a death, but a great making and a great giving, forging new elements within and then scattering them softly across the surrounding cosmos. It is a lovely thought to settle into, that the brilliant death of a star is also a sowing of new matter, the forge and the scattering of the very atoms of the world. Let us rest on where the heavier atoms of the cosmos come from, for many of them are forged in the great heat of stars and scattered in the blasts that end the greatest of them. The young universe held only the lightest of elements, the simple gases, and all the richer variety of atoms we know was built later, within stars and in their fiery deaths. Through their lives, the stars fuse light atoms into heavier ones, and in the searing heat of a supernova, still heavier atoms are forged, made in moments amid the blast. So the variety of the elements, the many kinds of atoms that make up worlds and water and living things, was woven slowly in the stars and scattered in their explosion. It is a humbling thought to hold that the rich array of atoms around us was not present at the beginning, but forged in stars and cast outward by their brilliant deaths. Here is a gentle and astonishing truth to settle into, that the iron carried in your own blood was forged long ago in the hearts and the deaths of distant stars. The iron that helps your blood carry breath through your body was made within stars, built up in their burning and scattered into space by the blasts that ended the greatest of them. That iron drifted for ages through the dark, mingled into the gas that formed our sun and world, and found its way at last into the rock and the water and into living things. So a small piece of the substance within you was once at the heart of a star, forged in its fire and scattered by its death, traveling across ages to become a part of you. It is a soothing wonder to rest upon that the very iron in your blood is the gift of ancient stars, a quiet trace of stellar fire carried gently within you tonight. There is another quiet gift of the stars carried within you, for much of the calcium that builds your bones was also forged in the fire and deaths of ancient stars. Calcium, the element that lends your bones their strength, was made within stars and scattered into space by the explosions that ended their lives in the deep cosmic dark. That stellar calcium drifted long through space, mingled into the cloud that formed our world, and gathered at last into the rock and the seas and into living bodies like your own. So the frame that holds you upright, the very bones within you, is built in part of atoms forged in stars, a quiet stellar substance carried in your body all your life. It is a gentle thought to hold as you settle, that your own bones are made in part of stardust, the calcium of ancient stars resting quietly within you through the night. Among the rarest gifts of dying stars are the precious metals of the earth, for much of the gold and silver in the world was forged in the fierce heat of stellar explosions. These heavy, precious atoms are made only in the most extreme of conditions, in the searing blasts of supernovae, and in the violent meetings of certain dense stellar remnants. Forged in those rare, fierce events, the gold and silver were scattered into space, drifting for ages before mingling into the cloud that formed our sun and world. So every fleck of gold and every gleam of silver on the earth traces back to the deaths of stars, precious atoms forged in cosmic fire and scattered softly across the dark. It is a lovely thought to settle into, that the gold and silver we treasure are the gift of dying stars, made in their fierce blasts and carried across ages to our world. Let us rest on the gentlest and truest wonder of supernovae, that you yourself are made in part of stardust, your body built of atoms forged within stars and scattered by their deaths. The iron in your blood, the calcium in your bones, and many of the other atoms that make you were not present at the beginning, but forged in stars and cast out by their explosions. Those atoms drifted long through the dark, gathered into the cloud that formed our world, and were woven at last into living things, into plants and creatures, and into you. So when we say you are made of stardust, it is not a poet's fancy, but a quiet, literal truth, your very substance the gift of stars that lived and died long before our world. It is a deeply soothing thought to hold as you settle toward sleep, that you are kin to the stars, your body woven of their scattered substance, a small living piece of the cosmos. It is worth resting on how the scattering of a supernova sows the seeds of new worlds, for the elements it flings outward become the very stuff of future planets and moons. The heavier atoms a star forges and scatters drift through space and mingle with the gas of the cosmos, enriching it with the substance from which rocky worlds can later form. Without the explosions of stars, the cosmos would hold only the lightest of gases, and worlds of rock and metal, of water and living things could never have come to be. So the brilliant deaths of stars are also the quiet beginnings of worlds, their scattered atoms gathering across the ages into new planets, circling new stars in the dark. It is a gentle wonder to hold that the wreckage of dying stars becomes the seed of new worlds, the scattered substance of one star gathering into the rock of another's planets. Let us follow the great shock of a supernova as it plows outward through space, for the blast does not simply scatter gas, but drives a powerful wave through the matter around it. The blown-away substance races outward as a great expanding front, and where it meets the thin gas drifting between the stars, it sweeps that gas up and presses it together. This shock front plows through space for thousands of years, gathering the thin matter before it, heating it and lighting it, drawing the surrounding gas into glowing shells. So a supernova reaches far beyond the star itself, its shock stirring and gathering the gas of the wide space around, shaping the matter for ages after the blast. It is a quiet wonder to hold, this slow plowing shock spreading through the dark, the blast of one star reaching outward to stir the gas across great reaches of space. There is a gentle and remarkable gift in the shock of a supernova, for as it plows into the gas around it, It can press that gas together and stir the birth of new stars. Stars are born when clouds of gas gather and grow dense enough to ignite, and the shock of a supernova can be just the gentle push that gathers a quiet cloud toward that birth. So a dying star in its very death can set new stars to forming nearby, its outward shock squeezing the surrounding gas into the dense clumps from which young stars arise. In this way, the end of one star can become the beginning of others, the blast of the old kindling the birth of the new, a quiet renewal woven into the death. It is a soothing thought to settle into that a supernova can sow new life among the stars, its shock stirring the gas to gather and ignite, death giving rise to birth in the dark. Let us rest a while on the gentle circle hidden in a supernova, the way a death gives rise to birth, the end of one star becoming the seed and the spur of others. The dying star scatters the elements that new worlds will need, and its shock presses the surrounding gas toward the birth of new stars, so its death enriches and renews the dark. From the wreckage of the old new stars kindle and new worlds gather, built of the very atoms the dying star forged and scattered, the cosmos renewing itself across the ages. So a supernova is not only an ending but a turning of a great quiet wheel, the death of one generation of stars sowing the birth of the next in the deep cosmic dark. It is a deeply calming thought to hold this gentle renewal, the end of a star folding quietly into new beginnings, the cosmos turning slowly from death toward birth. Let us turn now to the supernovae that people have actually witnessed, the rare bright deaths that flared in our own sky, beginning with one that shone brilliantly long ago. Now and then across the centuries, a star near enough has exploded and blazed so brightly that it could be seen plainly with the unaided eye, a startling new light in the heaven. Such a sight must have been wondrous and strange to those who saw it, a brilliant new star appearing where none had been, shining for weeks before slowly fading from view. These rare visible supernovae were carefully noted by watchers of the sky, their appearances recorded and remembered, a few precious sightings across the long span of history. So a handful of times the death of a distant star has flared bright enough to startle the watchers of the earth, a brilliant new light glowing for a while in the night sky. One of the most famous of these visible supernovae appeared in the year 1054, a brilliant new star that astronomers in China carefully watched and recorded. For weeks, this new star shone so brightly that it could be seen even in the daytime, a startling guest in the sky before it slowly faded over the following months. The careful records left of its appearance let astronomers today know just when and where that star exploded, a precious link between an ancient sighting and a remnant we still see. For where that brilliant new star once shone, there now drifts a beautiful expanding remnant, the soft glowing wreckage of the very star those watchers saw flare and fade. So the star of the year 1054 is a gentle bridge across the ages, an explosion seen and recorded long ago whose glowing remnant we can still study in the sky today. Let us rest on the remnant left by that famous old explosion, a soft glowing nebula of intricate gas that astronomers have come to know and study with great care. Where the brilliant new star of long ago flared and faded, there now spreads a beautiful expanding cloud of glowing filaments, the scattered substance of the star turned luminous. This remnant is a thing of delicate beauty, a tangle of fine bright threads of crimson and gold and teal, the gas of the exploded star woven into a soft glowing web. At its heart spins a tiny dense remnant, a pulsar, the crushed core of the star left turning swiftly, sweeping its faint beams across the surrounding glowing cloud. So that ancient explosion lives on as a soft luminous remnant, a glowing nebula with a spinning heart, the beautiful afterglow of a star that died nearly 1,000 years ago. Another brilliant supernova flared in the year 1572, a startling new star that careful watchers of the sky observed and recorded with wonder. This new star appeared suddenly among the familiar lights of the heavens, shining brightly for many months, a clear sign that the sky was not as changeless as had long been thought. A noted astronomer of the time studied it closely, marking its place and its slow fading, and its appearance helped stir new thinking about the nature of the distant stars. That a brilliant new star could appear and then fade away gently challenged old ideas of an unchanging heaven, and so the supernova became a quiet turning point in understanding. So the new star of 1572 was more than a passing wonder, a brilliant death that helped open minds to a changing cosmos, recorded carefully for the ages. Not long after, in the year 1604, yet another brilliant supernova flared in the sky, the last so far to have been seen plainly with the unaided eye in our own galaxy. This new star, too, was watched and recorded with care, shining for many months before slowly fading, a startling guest among the steady, familiar lights of the heavens. It was studied closely by a famous astronomer of the time, whose careful notes preserved the rise and fade of the new star for the understanding of later ages. Since that distant year, no supernova in our own galaxy has been seen so plainly with the unaided eye, making that sighting a precious and long-remembered one. So the new star of 1604 stands as the last great visible supernova of our galaxy, a brilliant death recorded long ago and awaited gently ever since. Pause now and imagine yourself held in a gentle cosmic calm, surrounded by the soft glow of a distant remnant, the deep dark settling vast and tranquil around you. There is nothing to fear in that soft cosmic quiet, only comfort, only the gentle glow of the scattered gas and the deep calm of a cosmos renewing itself in the dark. Let the quiet wrap around you. It asks nothing of you. Breathe slowly in that deep cosmic hush and let its gentle calm hold you, easy and still and safe. In more recent times, in the year 1987, a supernova flared in a small galaxy near our own, the nearest such explosion seen in centuries, and a gift to science. This explosion happened not in our own galaxy, but in a small neighboring one, close enough that its light reached us bright and clear, the nearest supernova in a very long while. Because it was so near and so well watched with modern instruments, This supernova taught astronomers a great deal about how the deaths of massive stars truly unfold. It was studied across the years as its light rose and faded, its expanding remnant followed closely, a rare close look at a great star's death seen with all the tools of today. So the nearby star of 1987 was a precious event, the nearest bright supernova in centuries, a brilliant death watched closely and learned from across the years. There is a special wonder in that nearby supernova of 1987, for from it astronomers caught a faint burst of neutrinos, the first ever sensed from a dying star. As we have rested upon, the collapse of a massive star pours out a vast flood of these ghostly particles, and from this near explosion a handful of them were at last detected. In great instruments deep beneath the ground, a faint burst of neutrinos arrived just before the light of the explosion, exactly as the science of the collapse had foretold. So this nearby blast confirmed in a beautiful way that the collapse of a massive star truly does release a great burst of neutrinos, a prediction met by a faint signal from the dark. It is a quiet marvel to hold that from a star dying in a neighboring galaxy, a few ghostly particles reached us deep underground, confirming the hidden heart of the explosion. Let us rest gently on a great star in our own sky that may one day end in a supernova, the red supergiant Betelgeuse, a brilliant ruddy point in a familiar constellation. Betelgeuse is a vast swollen star far heavier than our Sun, glowing deep red, the kind of massive giant that in time will run out of fuel and collapse in a great explosion. Because it is so large and so near, astronomers watch it with interest, knowing that it is in the late stages of its life and may someday end in a brilliant supernova. Were it to explode, it would be near enough to shine brilliantly in our sky, perhaps visible even in daytime, a startling and beautiful new light among the familiar stars. So Betelgeuse is a star to watch, a great red giant in its later years, a candidate to one day flare into a supernova bright enough to be seen plainly from the Earth. It is gentle and important to be honest about the timing of Betelgeuse's death, for though it may one day explode, no one can say when, and that day may be very far off indeed. It might explode in a time we would call soon by the measure of the stars, or it might shine on for many tens of thousands of years yet before its end finally comes. By the long, slow clock of the stars, even tens of thousands of years is a brief while, and so when astronomers say Betelgeuse may go supernova someday, they mean across vast time. So there is nothing to fear and nothing imminent in this, only a quiet astronomical waiting, the knowledge that a great star will end someday on a timescale far beyond our own. It is a calming honesty to rest within, that we know Betelgeuse will likely end in a supernova, and that we cannot say when, only that its day is its own and may be long off. It is worth resting on how gentle even a great supernova would seem from a safe distance, for though the blast is violent beyond imagining, from far away it is only a soft new light. A supernova in a distant galaxy reaches us as a faint point of light, its vast violence softened utterly by the immense reaches of space between us and the dying star. Even a nearer one, like Betelgeuse might someday be, would appear as a brilliant but harmless new light in the sky, far too distant to bring any harm to our world. So there is a quiet safety in distance, the violence of the explosion smoothed by the void into a gentle glow, a beautiful new light rather than any danger to the earth. It is a soothing thought to hold that the most violent events of the cosmos reach us softened by distance, brilliant deaths becoming only faint and gentle lights in our night. Let us rest on the supernova remnants that astronomers study today, the soft glowing clouds left by stars that died long ago, still drifting and glowing in our sky. Scattered across the heavens are many of these remnants, the expanding wreckage of old explosions, each a soft luminous cloud of gas spreading slowly through the dark. Astronomers watch these remnants closely, reading in their glowing gas the story of the star that died, the elements it forged, and the way its blast unfolded long ago. Each remnant is a kind of slow living record, the scattered substance of a star still glowing, still spreading, telling its quiet tale to those who study it across the years. So the remnants of old supernovae are gentle gifts to the watchers of the sky, soft glowing clouds left by ancient deaths, still teaching us as they drift through the dark. Among the loveliest of the remnants is one shaped like a great veil of glowing threads, a soft luminous web of gas spread delicately across a wide reach of the dark sky. This remnant is the wreckage of a star that exploded long ago, its gas now spread into fine drifting curtains and wisps, glowing soft in delicate shades across the void. The threads of this great veil curl and drift in graceful arcs, fine luminous filaments tracing the edge of the long expanding shell, soft and intricate in the deep dark. Astronomers study these glowing threads to learn how the old blast's gas has spread and cooled across the ages, reading the slow story of the explosion in its drifting veil. So this veil of glowing threads is a gentle marvel, the soft luminous remains of an ancient explosion, a delicate web of light still drifting quietly through the deep cosmic dark. Not all remnants are old and faded, for some are young and still fierce, the wreckage of more recent explosions, glowing bright and hot in the deep dark. A young remnant still carries much of the energy of its blast, its gas hot and bright, its shell compact and fierce, glowing strongly where an old remnant has grown soft and dim. In such young remnants, astronomers can study the freshly scattered substance of the star, the newly forged elements glowing vividly before the long ages have spread and cooled them. These bright young clouds are precious. A close look at the recent death of a star, the scattered substance still warm and glowing, the blast's story written fresh in the gas. So the young remnants are vivid living records, the bright hot wreckage of recent explosions, glowing fierce in the dark, the freshest pages in the long story of dying stars. It is worth resting on how astronomers find supernovae in our own time, watching the sky closely for the sudden brilliant new lights that mark a star's death far away. They survey great swaths of the heavens again and again, comparing each new view with the last, watching for a bright new point of light where none had shone before. When such a new light appears at the edge of some distant galaxy, Astronomers turn their instruments toward it swiftly, catching the rise and fade of a supernova as it unfolds. In this way, many supernovae are found each year in distant galaxies, each a star's death caught from afar, its light studied to learn the manner of its ending. So the finding of supernovae has become a steady, quiet watching, the sky surveyed again and again, the brilliant new lights of dying stars caught gently as they appear. There is a quiet marvel in how much astronomers can learn of a star's death from across immense distances, reading the whole story of an explosion in its faint, distant light. By studying the rise and fade of the brightness and the colors woven through the light, astronomers can tell what kind of star died, how it exploded, and what it scattered. Though the dying star may lie unthinkably far away, its light carries faithfully the marks of the blast, the elements forged, the speed of the gas, the manner of the end. So from a faint point of light in a distant galaxy, astronomers can reconstruct a great deal of the violent event that made it, reading the death of a star from afar. It is a gentle wonder to hold that so much can be known of so distant an event, the whole story of a star's death read quietly in its faint and traveling light. Let us rest on the great speed of the gas a supernova scatters, for it races outward far faster than the gentle mind can easily picture, thousands of kilometers in each second. At such a pace, the gas would cross the whole width of our world in a moment, and yet across the vast reaches of space it spreads only slowly, so immense are the distances. Astronomers can measure this great speed by reading the light of the expanding gas, watching how the blast's substance rushes outward in the moments and years after the explosion. Over the long ages, this swift expansion eases as the gas meets the thin matter of space, but at first it tears outward with a speed born of the great violence of the blast. So the scattered substance of a star is flung outward astonishingly fast, racing through the void, gradually slowing across the ages as it spreads into a soft, glowing remnant. It is worth resting gently on the energy a single supernova releases, for it is a quantity so vast that the gentle mind can hold it only as a kind of quiet wonder. In one brief blast, a supernova pours out more energy than our sun will give in all its long ages of shining, a release so great it is hard to set in any familiar measure. Most of that energy streams away unseen as the great burst of neutrinos, while a smaller share lights the brilliant flare and drives the gas outward at its tremendous speed. That so much energy should be unleashed in so brief a moment is among the most astonishing facts of the cosmos, the quiet fire of a star's whole life released all at once. So a single supernova is a release of energy beyond easy imagining, the gathered fire of ages poured out in a moment, most of it streaming silent and unseen into the dark. Let us rest on why supernovae are rare, why we so seldom see one in our own sky, for only a small share of stars end this way, and a galaxy holds many billions of stars. Most stars are small and gentle, ending their lives quietly without any great blast, and only the heaviest giants and certain dense remnants ever come to the supernova's brilliant end. Even in a great galaxy of many billions of stars, Only a few supernovae occur in a long span of time, so that bright nearby ones are seen only rarely across the centuries. So the rarity of these events is a matter of simple counting, the explosive deaths reserved for a small share of stars scattered thinly across the long ages of a galaxy. It is a gentle thought to hold that for all their brilliance, supernovae are rare and precious events, a few brief, brilliant deaths among the steady shining of countless quiet stars. It is worth resting on how often a galaxy sees a supernova, for though rare to us, across a whole great galaxy these brilliant deaths occur with a quiet, steady rhythm over time. In a galaxy like our own, a supernova is thought to occur only a small handful of times in 100 years, a slow, steady beat of brilliant deaths across the long ages. Most of these happen far across the galaxy, hidden behind its dust and distance, so that only a few across the centuries flare near enough to be seen plainly from the Earth. So, while a galaxy gives rise to supernovae fairly steadily over the ages, only the nearer ones reach us as bright visible lights, the rest unfolding unseen in the distant dark. It is a calming rhythm to rest upon, this slow, steady occurrence of supernovae across a galaxy, a few brilliant deaths each century, most of them quiet and far from view. There is a gentle waiting in astronomy for the next bright supernova in our own galaxy, for none has been seen plainly with the unaided eye since that distant year of 1604. Across the centuries since, no nearby star in our galaxy has flared so brightly, and so astronomers wait, knowing that one will come in time, though no one can say just when. When such a near and brilliant supernova does at last appear, it will be studied with all the great instruments of today, a rare close look at a star's death in our own galaxy. So there is a quiet anticipation woven through the science, the steady watching for the next bright nearby blast, a brilliant new light awaited gently across the long years. It is a soothing kind of waiting, this watching for the next great supernova, no urgency in it, only the quiet knowledge that one will come brilliant and beautiful in its own time. Let us drift back to the watchers of ancient skies, who first noted these brilliant new stars long before anyone understood what they truly were, and recorded them with care. Across many lands and ages, watchers of the heavens noticed when a new star appeared among the familiar ones, marking its place and its slow fading in their careful records. They could not have known they were seeing the deaths of distant stars, only that a brilliant guest had appeared and then departed, a wonder worth the noting and remembering. Yet their careful records have become precious to astronomers today, letting us match an ancient sighting to a remnant we still see, bridging the centuries with a single light. So the first hints of supernovae lie in those ancient skies and ancient records, brilliant new stars noted long ago by watchers who could not know they had seen a star die. Wander for a moment among soft drifting remnants in a calm, dark field, each one glowing slow and gentle, the whole deep void alive with their faint quiet light. Picture them lightly, those soft glowing shells drifting slow and gentle in the tranquil dark, calm and peaceful, glowing faint across the immense and silent void. And then let them fade, Return gently to your own quiet room, your own soft rest, the calm of the deep cosmos lingering with you like the peace of a still starlit night. It is worth resting on how the understanding of supernovae grew slowly across the ages, from a strange, unexplained wonder into the rich science we hold today. For long, a brilliant new star appearing and fading was only a mystery, a strange guest in the heavens with no known cause, recorded but not understood by those who saw it. As the study of the stars deepened, astronomers came to see these new stars as the deaths of distant suns, brilliant blasts ending the lives of stars far across the dark. Step by careful step, the picture grew, the two great roads to the blast, the forging of elements, the dense remnants, until the supernova became a thing richly understood. So the supernova has traveled in our understanding from a baffling wonder of ancient skies to a deep and beautiful science, the mystery gently unfolded across the ages. There is a gentle order in how astronomers name these brilliant deaths, marking each supernova by the year it was found, and a quiet label to set it apart from the rest. When a supernova is discovered, it is given the year of its finding and a small distinguishing mark, so that each brilliant death has its own quiet name in the records. In this way, the many supernovae found each year are kept gently apart, each labeled and noted, its light and its story preserved under its own name for later study. So even amid the many deaths found across the sky, each keeps its own quiet identity, named by the year and the order of its finding, a brilliant blast set down in the records. It is a small, calm orderliness to rest upon, this gentle naming of stellar deaths, each brilliant supernova given its place and its name in the long, careful chronicle of the sky. Let us rest on the colors woven through a supernova's light, for they are not a single white glow, but carry the hidden marks of the elements within the exploding star. When the light of an explosion is gently spread out, it reveals a pattern of bright and dark lines, the fingerprints of the atoms in the blast, each element leaving its own mark. By reading these colored fingerprints, astronomers can tell which elements the supernova holds, learning what the star was made of and what it has forged in its fiery end. So the color in the light is a kind of quiet message, the elements of the dying star written into the beam, legible to those who learn to read the patterns within the glow. It is a gentle wonder to hold that the very substance of a distant exploded star can be read in the colors of its light, the atoms of the blast revealed in the gentle glow. It is worth resting on how the light of a supernova changes over time, for it is not a steady glow but a shifting one, its colors and brightness evolving across the weeks. In the first days the light shows one pattern, the gas hot and dense, and as the cloud expands and cools and thins, the colors shift, revealing the changing nature of the blast. By watching how the light changes from night to night, astronomers can follow the unfolding of the explosion, reading the cooling and spreading of the gas in its shifting glow. So, a supernova's light is a slow story told over time, the changing colors tracing the changing gas, the whole evolution of the blast written gently into the fading beam. It is a quiet marvel to hold that the entire unfolding of a star's death can be followed in the slow shifting of its light, the explosion's story read across the changing nights. Let us rest on the two things a collapsing supernova leaves: the dense heart and the scattered body, the tiny crushed remnant within, and the great glowing cloud spread without. At the center may rest a neutron star or a black hole, the crushed core of the giant, tiny and dense, while all around it the star's outer substance drifts as a glowing cloud. So a single explosion gives rise to two very different things at once: a small dense remnant at the heart, and a vast soft glowing remnant spread wide across the surrounding dark. The dense heart and the scattered body are two halves of one event: the inward crush and the outward blast, the crushed core and the flung out gas, born together in the collapse. It is a gentle thought to hold this pairing of the tiny, dense heart and the vast, soft body, the two remnants of a single death drifting together in the deep cosmic dark. Let us rest a while on the astonishing density of a neutron star, for its matter is packed so tightly that a single small spoonful of it would outweigh a great mountain. In the crushing collapse of the core, the matter is squeezed beyond all ordinary bounds, the particles pressed so close that a tiny volume holds an almost unimaginable mass. So if one could somehow hold a small spoonful of neutron star matter, it would weigh more than a whole mountain of ordinary rock. So densely is the stuff of it packed. It is a strange and gentle wonder, this density beyond imagining, the whole mass of a star crowded into a sphere the size of a city, a teaspoon of it heavier than a hill. So the neutron star is among the densest things in all the cosmos, a tiny crushed remnant of unthinkable weight, left quietly at the heart of an old explosion in the dark. There is another wonder hidden in the dense remnants of supernovae, for many neutron stars carry magnetic fields of extraordinary strength, woven through their crushed matter. When the great core of a star collapses, its magnetism is concentrated along with its matter, so the tiny remnant can hold a magnetic field far stronger than any in our world. These powerful fields help shape the beams a pulsar sweeps across the dark, channeling its light from the poles as the dense remnant spins swiftly in the deep cosmic night. So the dense hearts of remnants are not only astonishingly heavy, but also strongly magnetic, their fields concentrated in the collapse, woven through the crushed matter at the center. It is a quiet marvel to hold these tiny, dense remnants with their immense magnetism, spinning steadily in the dark, the strong magnetic hearts left behind by dying stars. Let us rest on the steady beat a pulsar keeps, for as it spins, it sweeps its beam past us again and again, a faint regular pulse reaching us across the immense dark. Each turn of the spinning remnant brings its beam around to face us for an instant, and so we catch a steady rhythmic flicker, the pulse from which these remnants take their name. Some pulsars turn slowly, their beat a gentle rhythm. Others spin many times each second, their pulse a swift, steady patter from the dense heart of an old explosion. So a pulsar is a kind of cosmic timekeeper, its beam sweeping round with great regularity, a faint, steady beat marking the swift turning of a crushed remnant in the dark. It is a soothing thought to settle into, these dense remnants keeping their steady rhythmic beat across the void, the gentle pulse of dying stars marking time in the deep cosmic night. It is worth resting on how a supernova remnant lights the dark around it, for the scattered gas does not glow on its own alone, but is lit and warmed in several gentle ways. The freshly made radioactive elements warm the gas from within at first, while the energy of the blast and the shock against the surrounding matter light it from without. As the shell plows into the thin gas of space, that meeting heats and lights the gas so the remnant glows brightest where its expanding edge presses against the surrounding dark. In these ways, the scattered substance of a star is lit into a soft, luminous cloud, glowing by the warmth of its own newborn elements and the energy of its outward blast. So a remnant shines by a gentle gathering of light, warmed within and lit without, the scattered star turned into a soft glowing cloud drifting through the deep cosmic dark. Let us drift among the colors of a glowing supernova remnant, for its gas shines in soft and varied hues, each color the gentle signature of a different element within. The gas of a remnant glows in shades of crimson and gold and teal and violet. Each hue arising as a particular element is warmed and lit, painting the cloud in soft color. So a remnant is not a single shade, but a soft tapestry of color, its glowing gas tinted by the many elements the star forged and scattered, woven through the drifting cloud. By reading these colors, astronomers learn which elements glow where within the remnant, mapping the scattered substance of the star by the soft hues of its glowing gas. It is a lovely thing to rest the mind upon, these soft colors of a remnant, the crimson and gold and teal of glowing gas, the scattered star painted gently across the dark. It is worth resting on the slow cooling of a remnant's gas, for after the fierce heat of the blast, the scattered substance cools gradually across the long ages, fading as it cools. In the first days, the gas is searing hot and brilliant, but as it expands into the vast cold of space, it cools slowly, its glow gentling across the weeks and the years and the ages. As it cools, the gas glows in softer colors and fainter light, the fierce brilliance of the blast easing into the gentle luminance of a drifting nebula in the deep dark. Over thousands of years, the cooling continues, the remnant growing ever softer and dimmer, until at last its faint glow merges gently with the thin gas of the surrounding space. So the cooling of the gas is a long and gentle fading, the fierce heat of the blast easing across the ages into the soft, quiet glow of a remnant drifting through the dark. Let us rest on what happens when a supernova remnant meets the gas and dust around it, for the expanding shell does not drift alone, but stirs and gathers the matter it reaches. As the remnant spreads outward, it sweeps into the thin clouds of gas and dust between the stars, pressing them together and lighting them and shaping them as it passes. Where the shell meets a denser cloud, the gas is gathered and stirred, and in time such a gathering may grow dense enough to kindle into new stars in the wake of the blast. So a remnant reaches beyond itself, stirring the matter around it, gathering the gas of nearby clouds, weaving the wreckage of one star into the surrounding fabric of the dark. It is a gentle thought to hold this meeting of a remnant with the matter around it, the scattered star reaching outward to stir and gather the gas of the surrounding space. It is worth resting on how supernovae have slowly enriched the cosmos, adding their forged elements to the gas of space across the long ages, deepening the variety of matter. The young universe held only the lightest gases, but with each generation of stars that lived and died, the gas of the cosmos was seeded with more of the heavier elements. Supernova by supernova across vast spans of time, the cosmos grew richer in the heavier atoms, the gas from which new stars formed carrying more of the forged elements. So the very recipe of the cosmos, the mix of elements that fills its gas, has been slowly enriched by the deaths of stars, each blast adding its forged substance to the whole. It is a gentle wonder to hold this slow enrichment, the cosmos growing richer in the elements of life and worlds across the ages, seeded by the scattered substance of dying stars. Let us rest on why our own world holds such a rich variety of substances, the metals and minerals and the elements of living things, for much of it traces to dying stars. Our world is made of a great variety of elements, far more than the simple gases of the young cosmos, and this richness was gathered from gas enriched by generations of dying stars. The cloud that formed our sun and world was seeded with the forged elements of earlier supernovae, and so our world holds the scattered substance of stars that died long before it. So the very richness of the earth, its metals and rocks and the elements within living things, is a gift of ancient stars gathered from gas enriched by their brilliant deaths. It is a soothing thought to settle into, that the variety of our world is the inheritance of dying stars, the scattered elements of ancient supernovae gathered into the earth. It is gentle and worth noting that our own sun will not end in a supernova, for it is far too small a star to ever explode in that dramatic way, and its end will be quiet. Only the great giants, far heavier than the sun, can collapse and explode, and our sun, a modest, steady star, will instead end its long life by swelling and then gently fading. In the far future, the sun will slowly shed its outer layers and settle into a small cooling ember, a quiet end with no great blast, no brilliant flare, only a gentle fading. So there is nothing to fear for our own star, which will not explode but will live out its long life and then fade quietly, far in a future beyond all our reckoning. It is a calming thought to rest upon, that our sun's end will be gentle and far off, a quiet fading rather than a blast, the supernova reserved for the great giants alone. There is a quiet irony in the lives of the greatest stars, for the very stars massive enough to end in a supernova are also the ones that live the briefest lives of all. A great massive star burns through its fuel furiously, shining brilliantly but using itself up swiftly so that its whole life is short compared with the long ages of smaller stars. So the giants that will end in a blast race through their lives in a relatively brief span, blazing bright and then collapsing, while the small quiet stars shine on far longer. It is a gentle paradox to rest upon that the brightest and greatest stars are the most fleeting, their brilliant lives brief and their ends dramatic, while the modest stars endure. So the supernova is the swift, bright ending of a swift, bright life, the greatest stars burning briefest and ending grandest, a brief, brilliant arc from birth to blast in the dark. Let us rest on the quiet that comes before a massive star's collapse, for in its final stages the great star burns through ever heavier fuel, building toward its end in a hidden hush. Deep within, the star fuses heavier and heavier elements in faster and faster stages, each burning briefer than the last, building toward the iron core that will end its fire. From outside, the star may look much as it always has, a great steady giant glowing in the dark, even as within it races through its final stages toward the coming collapse. So there is a hidden quiet before the blast. The great star outwardly steady, while its core builds swiftly toward the iron that will fail, the collapse drawing near unseen within. It is a gentle thought to hold, this quiet before the great event, the giant glowing calm in the dark, while deep within its fate is gathering toward the sudden brilliant end. There is a gentle picture of a massive star near its end, its interior arranged in layers like the layers of an onion, each layer burning a different fuel toward the iron core. In the final stages, the great star holds layer upon layer within it, the outer layers burning lighter elements and the deeper ones heavier, each nested within the next. At the very center sits the growing core of iron, surrounded by shells of burning, each layer fusing its own fuel, the whole giant arranged in concentric burning layers. So a dying giant is a thing of nested layers, an onion of burning shells around an iron heart, each layer contributing to the slow building toward the collapse and the blast. It is a quiet wonder to hold this layered structure of a dying giant, the nested shells of burning around the iron core, the great star ordered within toward its coming end. It is worth resting on the several forms the collapse of a massive star can take, for not every great giant explodes in just the same way, and astronomers sort them gently into kind. Some giants explode still wrapped in their outer layers of hydrogen, while others have shed or lost those outer layers before the end, so their blasts show a different light. These differences in the star's outer layers give rise to the several kinds of collapsing supernovae, each marked by what the dying giant still carried when its core fell in. So the collapse, though always the same at its heart, wears different outward forms depending on the star, the brilliant blast taking several shapes among the great giants. It is a gentle thought to hold this variety within the giants' deaths, the same inward collapse clothed in different outer layers, the blast wearing several quiet forms. Let us rest on the giants that shed their outer layers before the end, for some great stars cast off much of their gas in strong outflows long before their cores at last collapse. In their later years, some massive stars drive great streams of gas outward, shedding their outer layers into space, so that when the core collapses, little of the outer star remains. Such a star, having lost its outer gas beforehand, explodes in a blast that shows a different light, the marks of the shed layers absent from the glow of the collapse. So the shedding of layers shapes the death to come, the giant casting off its gas in life so that its final blast wears a different aspect, marked by what it had already lost. It is a gentle thought to hold this casting off of layers before the end, the great star shedding its substance in life, and then collapsing, its blast shaped by what it had let go. Behind all we know of supernovae lies the long quiet watch of the astronomers, the steady surveying of the sky, and the careful study of each brilliant death as it appears. It is slow and devoted labor, the watching of countless galaxies for a new point of light, the swift turning of instruments toward each blast, the long following of its fading glow. From this steady watching the science has been built, the kinds of supernovae sorted, the elements read, the remnants mapped, each careful study adding its quiet thread. So our knowing of these brilliant deaths rests on devotion, on the long, calm labor of those who watch the sky closely and follow each dying star across its rise and fade. It is a gentle thing to admire this devoted watch, the astronomers reading the deaths of distant stars, building our understanding of the supernova across the steady years. It is gentle to follow how the study of a single supernova unfolds, from the first new light caught in a survey to the long following of its fading across the weeks and months. First comes the finding, a bright new point noticed where none had shone, and astronomers turn their instruments toward it swiftly to catch the explosion as it brightens. Then comes the following, night after night, as the light rises to its peak and slowly fades, its colors read, its kind determined, its story gathered from the changing glow. And at last, long after, the expanding remnant may be studied, the scattered gas followed as it spreads and cools, the blast's afterlife traced across the years that follow. So the study of one supernova is a long, gentle unfolding, from the first caught light to the slow spreading remnant, a star's death followed with care across all its stages. Let us rest on what the neutrinos of a supernova can tell us, for these faint particles carry words straight from the collapsing heart of the star where no light can escape. Because the neutrinos pour out from the very core and slip through everything, they reach us bearing news of the collapse itself, the hidden inner event behind the brilliant blast. So when astronomers catch a burst of neutrinos from a dying star, they learn of the collapse directly, glimpsing the inner heart of the explosion that the light alone cannot show. This is why the neutrinos caught from the nearby supernova of 1987 were so precious, a faint signal from the very heart of a collapse confirming the inner story. It is a quiet marvel to hold that these ghostly particles bring us word from the hidden core of a dying star, the inner collapse revealed in a faint burst from the dark. Let us drift for a moment into the deep, quiet instruments that listen for the neutrinos of dying stars, great detectors resting far beneath the ground in stillness and dark. These instruments are built deep below the surface, shielded by the rock above, waiting in their stillness for the faint touch of a neutrino from a star collapsing somewhere in the dark. They hold great volumes of clear material, watched by sensitive eyes that would catch the faint flash a passing neutrino makes, so rare and so faint a touch from the deep cosmos. So when a massive star collapses anywhere near enough, these deep listeners may catch the faint burst of neutrinos, a signal from the heart of a blast reaching the quiet dark below. It is a peaceful image to settle into, these silent deep instruments waiting in the dark, listening across the years for the faint whisper of a dying star's collapse. It is worth resting on the many kinds of eyes astronomers turn upon a supernova, for they study these blasts not in one light alone, but across many forms of light at once. A supernova gives off more than the light our eyes can see, and astronomers gather all of it, the visible glow and other unseen rays, each kind revealing a different part of the blast. By studying a supernova across these many kinds of light, astronomers build a fuller picture of the explosion, the hot inner gas, and the cooler outer shell, each revealed in its own way. So a single blast is watched with many eyes at once, each form of light telling its own part of the story, the whole event read more deeply through their gentle combination. It is a quiet marvel to hold this watching of a dying star across so many kinds of light, the many eyes of astronomy gathered upon a single distant blast in the dark. It is worth resting on how the understanding of supernovae grew across the years, from the first sense that a new star was a death to the rich science we hold today. It began with the recognition that these brilliant new stars were not births but deaths, the endings of distant suns flaring out across the dark, a startling and powerful idea. Then came the sorting into kinds, the two great roads to the blast, the forging of elements, the dense remnants, each new insight adding to the slowly deepening picture. As the years passed and the instruments grew finer, the science gathered strength, the supernova becoming one of the well-understood great events of the cosmos. So the idea of the supernova has a gentle history of its own, a slow building of understanding across the years, from a brilliant mystery to a deep and beautiful science. Let us rest on how supernovae shape the life of whole galaxies, for their blasts stir the gas of a galaxy, enrich it with elements, and help set the pace of new star birth. Across a galaxy, the steady occurrence of supernovae stirs and heats the gas between the stars, shaping how that gas gathers and cools and forms new stars over the ages. And each blast enriches the galaxy's gas with forged elements. So the galaxy grows richer in heavier atoms with each generation of stars that lives and dies within it. So supernovae are woven into the slow life of a galaxy, stirring its gas, enriching its substance, helping to set the gentle rhythm by which new stars are born across the ages. It is a soothing thought to hold that the deaths of stars help shape the life of galaxies, the brilliant blasts stirring and enriching the gas from which new stars arise. Let us drift among the thin gas that lies between the stars, for it is into this gas that supernovae scatter their substance, and from this gas that new stars are born. Between the stars of a galaxy drifts a thin haze of gas and dust, sparse and cold, the great reservoir of matter from which stars form and into which they scatter when they die. A supernova flings its forged elements into this thin gas, enriching it, and its shock stirs and gathers the gas, shaping it toward the dense clumps where new stars may form. So the gas between the stars is both the cradle and the resting place of stars, the matter from which they rise and the place to which the dying scatter their substance. It is a gentle thought to hold this thin gas between the stars, stirred and enriched by the deaths of stars, the quiet reservoir from which new stars are gathered across the ages. It is worth resting on why the cosmos grows richer in elements over time, for with each generation of stars that lives and dies, more of the heavier atoms are forged and scattered. The earliest stars formed from the simple gases of the young cosmos, but as they died, they scattered heavier elements, enriching the gas from which the next stars would form. So each generation of stars inherits a gas a little richer than the last, and the cosmos grows steadily fuller of the heavier atoms, supernova by supernova across the age. This slow enrichment is why later stars and their worlds can hold the variety of elements needed for rocky planets, and in time for living things gathered from the dying of the old. It is a gentle wonder to hold this steady enriching of the cosmos, the gas growing richer in heavier atoms with each generation of stars, the dying sowing the substance of the new. Let us rest on the generations of stars, the long succession of stellar lives and deaths across the ages, each generation built in part from the scattered substance of the last. The first stars formed from the simple young gas, lived their lives and scattered heavier elements when they died, seeding the gas from which later stars would be born. So the stars rise in generations, each gathered from a gas enriched by those before, each scattering its own forged substance in turn for the generations yet to come. Our own sun is such a later star, formed from gas enriched by earlier stars that lived and died, carrying within it the scattered substance of generations long past. It is a soothing thought to hold this long succession of stellar generations, each rising from the scattered substance of the last, the cosmos renewing its stars across the ages. Supernovae have become one of the great recurring wonders in the story of modern astronomy, woven through the way we now understand the lives and deaths of stars and the cosmos. From the ancient sightings of brilliant new stars to the great surveys of today, the study of these blasts has drawn the attention and the wonder of many careful minds. They stand among the grand events of the cosmos, brilliant and rare, forging the elements, leaving strange remnants, measuring the very distances of the universe. So supernovae live not only in the sky, but in the human story of trying to understand the sky, great events carried forward by the curiosity of those who study them. It is fitting that so dramatic an event should hold so large a place in the story of science, the death of stars drawing forth a long and gentle effort to understand it. For as long as people have watched the heavens, they have wondered at the rare, brilliant new stars that flared and faded, and that wonder lives on in the science of today. From the ancient watchers who recorded a startling new light to the astronomers who follow each distant blast, the death of stars has called forth a long and devoted wonder. There is something in the brilliance and the rarity of a supernova that invites this wonder, the sense of witnessing a great cosmic event, a star's whole life ending in a single blaze. So the study of supernovae is a story of devotion, of minds drawn again and again to these brilliant deaths, finding in them a wonder worth the long and careful pursuit. It is a gentle inheritance, this long wonder at dying stars passed down through all who have watched the heavens, and tonight we take our own quiet place within it. There is a quiet beauty in how the brilliance of a supernova is held in memory long after its light has faded, in the records of watchers and in the remnants left drifting in the dark. A supernova blazes brilliantly for only a while, and then fades, yet its memory endures in the careful records of those who saw it, and in the glowing remnant it leaves behind. So even after the brilliant flare has dimmed, the death is not forgotten, its story preserved in the chronicles of the sky and written in the soft glowing gas it scattered. In this way, a supernova lives on past its brief brilliance, held in quiet memory by the watchers and by the drifting remnant, its death remembered across the long ages. It is a gentle thought to settle into, this lasting memory of a brilliant death, the supernova fading from the sky, yet enduring in record and in remnant through the years. There is a deep honesty at the heart of the science of supernovae, a willingness to say plainly both what we know well and what we are still learning, and that honesty is a comfort. We know with confidence the two great roads to the blast, the forging of elements, the dense remnants, and we hold honestly the details still being studied and refined. When a thing is uncertain, like the timing of a great star's future death, we say so plainly, never dressing a guess as a settled fact, keeping faith with the true state of our knowledge. This honest holding is a quiet strength of science, the readiness to be sure of what is sure and to leave the uncertain gently open, neither overstating nor pretending. So we rest tonight in that honesty, sure of much about these brilliant deaths and humble before what remains to be learned, holding the known and the open with an even hand.